Welcome to part two of the pizza delivery case. In part one, we took a look at pizza delivery, pizza fulfillment times, and came to the conclusion that 28 minutes, 20, 28 minutes right here was probably the sweet spot for most, both customer and the organization, but we only had a single data point. So we needed to collect some more data and to also collect some critical to quality variables, not just total lead time in the system, but some of those important factors that are contributing to the total lead time. So in part two, we go to the pizza delivery shop, talk to the pizza owner, and the pizza owner provides this data table. This is an example of a data table that didn't follow a good data collection plan. And in part two, what we're really going to be doing in terms of learning objectives is to take a look at what is included in a good data collection plan by looking at an example of a poor data collection plan. Specific things include the types of data to consider in a process improvement project, continuous or discrete, and the effects that the data type has on your sample size consideration. We'll also take a look at operational definitions that should be created so that all data measures are collecting the same data in the same way. We'll explore proxy data and its effect on process improvement work and wrap things up with making sure that the CTQs that you end up selecting are based upon the analysis and not based upon just the ease of collection or based upon one silo within the entire enterprise system process. One of the first things that is discussed is how each of these columns represents different types of data, where the tip data is discrete data, sometimes called attributes data, and the time to make the pizza data is continuous data. For more information on the differences between continuous and discrete data, I'm going to have you refer to the other video, sometimes called the putt-putt case video. Also, let me pull up a quick little image here that summarizes the differences between continuous and discrete. One of the big differences between continuous and discrete data is the amount of data that you need to collect. For discrete data, the amount of data that you need to collect to be 95% confident that what you're observing is a reflection of what's going on in current state or an accurate reflection of what to expect to see in a future state condition if things don't change. For discrete data, we're talking about 1,400 data points. And when it comes to continuous data, that number is much smaller with continuous time-based data, money, weight, other physical phenomena, distance, height, barometric pressure, temperature. The amount of data that you need to collect is far lower. Okay, now with the screen cleaned up a little bit, let's go back to the original data table. One of the conclusions we find with this poorly collected data is there's just not enough. There's not enough discrete data. If we were going to use this tip data, there's not enough continuous data, time to make the pizza data. But within the columns, there's also problems. Let's explore the tip data for a moment. You know, what is tip data anyway? What we come to conclusion in classroom discussion is that this is an example of proxy data, where one of the critical to quality variables that was needed was customer satisfaction. But for whatever reason, the organization didn't have that. So tip data was used as proxy data. Proxy data can be used in process improvement work, but it has to be a good approximation of the phenomena that you're trying to study. There are a lot of reasons why tip data may not be a good proxy for customer satisfaction. You may live in a household where you have a minimum percentage tip that you provide regardless if you get good or bad service. You may be in a household where even if you had great service, you're unable to tip because you just don't have that extra available funds. So tip data would be thrown out, not a good example of proxy data. A bad example of proxy data. Time to make the pizza. Time to make the pizza is continuous data, but what does time to make the pizza mean? Are we talking about the bake time? Are we talking about the build time? Yeah, actually, let me do this. Let me bring up an image of our process map to describe further what I mean by what does this time to make the pizza mean? All right, I brought up a process map to help further illustrate what I mean here when I'm saying, what does time to make the pizza mean? Um, is it the build time, the time it takes to make the pizza? Is it the bake time, the time it takes to cook the pizza? Is it everything from the beginning of the order to when it leaves the pizza shop? Or is it everything from the beginning of the order to when it arrives on the doorstep, what we'd call the total lead time in the system? It's unknown. This is an example of a critical to quality variable in which we don't have a very good operational definition for what that variable means. Let's take a look at what a good operational definition consists of. All right, I just added another page from the workbook describing operational definitions. Part of the pizza case explores how in a good data collection plan, you're going to have operational definitions to make sure that all measurers are collecting the same type of data in the same way. And I think the key piece here, I'm going to zoom in on it even, the key piece here is that all good operational definitions should provide measurers with precise definitions of what it is to be measured, how you're going to measure it, and the boundaries to measure. In the part 2 of the pizza case, we just don't have that. We have no idea what time to make the pizza means. So good op defs are going to need to be provided to make sure that everybody's working on the same type of phenomena. Finally, one of the things discussed in the class in part 2 of the pizza case is how this information is only a fraction of the phenomena that really needs to be studied to understand what's going on in current state. Whether this is the bake time or the build time or a combination of the two, that's only part of the end-to-end experience that the customer is experiencing. So we're going to want to make sure that we're capturing in current state data that reflects customers' experience, both in a positive and negative fashion. We're probably going to want to identify other critical equality variables that affects this, whether we're taking a look at total lead time or customer satisfaction or whatever the customer performance metric is that we're interested in. So things like the delivery time, the bake time, the build time, those are all important, but we might want to also capture CTQs that are around staffing levels. There could be CTQs around time of the day or day of the week. This might help us better understand, are we in a busy period or a slow period? Is it Super Bowl Sunday, one of the busiest times of the year for pizzas, or is it a Tuesday in July, not a very busy time period? These are all examples of the variables that we might want to consider collecting. Our job is to make sure that we identify them and then we do some CTQ prioritization. To make sure that the most important data for current state is collected. And in part 3, we'll take a look at a better set of data, something that has better sample sizes, more operational data, data that reflects the true customer experience. We'll take a look at that in part 3.